Multiply.
Yeah, multiply. Yeah. So I'm going to take this entire term, 4k, multiply it by the 9k, and then I'm going to take it again and multiply it by the negative 9. All right. So I know it looks confusing with the variables. That's why we take it one step at a time. You just do the numbers first. So 4 times 9 is 36. And then k times k. Well, when I multiply two variables, and they're single variables, like k times k, you kind of smash them together and throw an exponent on top. Because there are two now, it becomes k squared. If it was like 5k's times 5k's, like k to the 5th times k to the 5th, it would be k to the 10th. You just take all the k's and just add them together and throw the new exponent on there, okay? That only happens when you multiply them, all right? When you add like terms like that, they stay as regular k, all right? And then 4k times negative 9, I'll do negative 9 times 4, which is negative 36, and then since there's only 1k, it just comes with, all right? And then don't forget to throw on that 3k in the back, because now we have to combine like terms, all right? The 36k squared does not have any other k squareds around, so that stays as is, okay? K squared is a different variable than regular k. Keep that in mind, okay? And then we combine those, we add the numbers together, so negative 39, because negative 36 minus 3, and then just bring the k with, and then you're done, okay? So this one over here is pretty close, pretty much the same, but I'll let you guys do that. This one is more simplifying. We just have to plug in numbers first. So you're going to use PEMDAS. But before you do, right, we have all these variables. You can't do anything when there's a lot of variables there. It tells us what each variable is worth. It says use p equals 4 and r equals 6. So anytime you see a p, you're going to throw in 4 instead. Anytime you see an r, you throw in 6 instead. So r plus r divided by 6 minus p turns into 6 plus 6 divided by 6 minus 4. Okay? And then you follow the order of operations. Well, PEMDAS says I have to do division first. So I have 6 plus, then do that, which is 1 minus 4. Right? 6 divided by 6 is 1. And now you have adding and subtracting, so you can just go right straight across from left to right. 6 plus 1 is 7, minus 4 is 3. Okay? So that the one over here is just like that, but I'll leave that to you. Okay, any questions on those two from you gentlemen? Okay, let's go down here. So I'm going to need some audience participation, all right? So let's try to remember we talked about angle relationships a few days ago, like vertical angles, linear pairs, alternate exterior and alternate interior angles, and then same side exterior, same side interior angles, and then corresponding angles, all right? So first, let's just identify. All we're doing is identifying what types of relationships these are. So 1 and 3, what kind of angles are these? They just share a vertex, okay? They're opposite each other. They're congruent with each other. What do we think? Feel free to use the chat if you want, private chat if you want. What are 1 and 3? Think vertex, right? Sounds very similar. They share a vertex. Come on, gents. Give me something. Give me something. Zeke, join us. Help me out. What are angles 1 and 3? What kind of angles are they? They share a vertex. They're opposite. We're stumped. What do we got here? Come on, guys. They're opposite each other. They share a vertex. They are, by the way, this is the link under my name, Zeke. Vertex. Give me something, guys. Come on. Show me that you're here, that you're present. Everardo, give me a thumbs up or something. Show me that you're here. All right. Okay. All right. This is vertical angles. You guys need to know this. Okay. You need to know this. All right. The vertical angles are opposite each other. They are congruent. Okay. Next one. Angle 3 and angle 2. Anyone know this? They are next to each other. They make that line. They share a line right here. They add up to 180. What do we think? Line, there's 2 of them. Linear pair. Okay. Keep that in mind. Our test is next Friday, by the way, if you didn't remember that. Okay. Now angles 2 and 8. They're in the same spot, different lines. Same spot, different lines. Same spot, different lines. They are congruent. Corresponding angles. Okay. And then we have angle 8 and angle 6. All right, give me something here. Angle 8 and angle 6, they just share a vertex. We've sort of already talked about it. Not sort of, we have talked about it already.
Vertical.
Yes, thank you, Brandon. Vertical angles. They're vertical, they're opposite each other. They're equal. And then our last pair here, we have 6 and 1. They add up to 180. They're on the same side of that transversal line, that slanted line.
Linear?
No. In order to be linear, they have to be right next to each other, just like 2 and 3. They got to be right next to each other, okay? Good guess, though. They got to be right next to each other for a linear pair. This, they're on the same side of that line. They are, if we close our parallel lines, they are on the outside of it. So it's the exterior. Same side exterior angles. Okay? They're outside that box. All right? So as you can see, all these angles, they're either equal with each other or they add up to 180. All right? So that's going to come in handy when we find our angle measures. Okay? So if angle, this is the pattern that I was telling you about, okay? A few days ago. If angle 1 is 75, what other angles? We got to find the other angles. So first we want to start with what other angles are 75 degrees? What do we know? What do you think? Look up here, right? Which ones were equal with each other? What other angles are 75 degrees? Stick with this cluster, 1, 2, 3, and 4. What other angles is 75? Think vertical angles. Which one's vertical with 1?
2.
No, that's a linear pair, right? They're next to each other. They only
3.
have, not 3, those are linear pairs too. They only share the vertex, so it has to be directly across from 1, directly across.
4.
So 4, yeah, 4. Think of an X, right? You have an X here, only this side and this side, those are vertical, right? This side and this side, those are vertical because they don't share a side. They're not directly next to each other, okay? Those are vertical angles. What now, using corresponding angles, right? 1 is in the top right, or just in the right section of that intersection. Looking at 5, 6, 7, and 8, which angle is also in the right section of that intersection?
5.
Yeah, 5. So they have to be the same, okay? They have to be the same. And then going back to vertical angles, 5 and 6 are vertical, so they have to be the same, right? Because they share this vertex, all right? Now, how do I find, like, all the other ones, okay? Like, all right, let's stick with the top. How do I find angle 2 if 1 and 2 are linear pairs? How do I find angle 2? They add up to 180 together. So how can I find angle 2?
Number 3.
What is it? Said something about numbers? How can I find, if 1 and 2, if I add those two together, I make 180. So, and I know that 1 is 75. How can I find number 2? What can I do with 180?
Add 75 and 75 and then subtract 180 or something like that?
Not quite. I only want angles 1 and 2, right? Only angles 1 and 2 make 180 degrees. So I'm going to take 180, and since I already know one of them, I'm going to subtract 75. What I get, which is 105, that is angle 2, because 75 and 105 make 180. Okay? That's angle 2. And because angle 2 and 3 are vertical, this is also 105. Now we come back to the corresponding angles, right? 2 is corresponding with 7, so that's got to be 105. 7 and 8 are vertical, so that's got to be 105. So you see this pattern here? 105s across the board. And you have 75s, whoops, 75s across. They kind of zigzag each other, okay? That is our, that's our pattern. And you'll be able to see it again here with number 2. I throw on angle 1 is 35 degrees. What other angle is 35 degrees? Anybody?
Number 3.
3 is 35. What angle's up in the top cluster? 2, 4, 6, and 8, or 2, 4, 7, and 8? What do we think? If you took all of the angles in 1, 3, 5, and 6 and plucked them out of the page and put them on top of the intersection of 2, 4, 7, and 8, they're going to be in the same spot, right? So 1 would go with which one? Come on, guys. 1 goes with 4. 1 goes with 4. They're in the same spot, right? Kind of the top section. And 4 and 2 are vertical. And then we do our 180 minus 35 to get the other one, which is 145. That means this is 145. This is 145 because those are the same. And then 8 and 5 are in the same spot, so that's 145. And then 5 and 6 are vertical, so that's 145. And so again, we have our pattern going forward. Okay. All right, 3 and 4 for you guys. But stay in this room. Miss Seha is going to come in. Why don't you click on her link, and I will send her over. Okay. So stay here.
All right, we are done. Oh, your mic is off, Mr. Owens.
All right, cool. I'll send you over to the boys.
Okay.
All right. Little girls. Happy Thursday. It's almost over. We're almost done. I promise. Okay. Just click on my name. We'll get through this pretty quick. It'll be faster if we get some audience participation. Okay. All right. So let me share my screen. All right, the top 4 are the simplifying, okay? The first 2 on the top are distributing. What happens when we distribute? Do we multiply, divide, add, or subtract?
Multiply.
Multiply, yeah. So I'm going to take the entire term, 4k, and multiply it by 9k. I'm also going to take 4k and multiply it by -9, okay? So I know it could be weird when you're multiplying variables, but we'll get through it, okay? First thing you just want to multiply is the numbers. So 4 times 9 is 36. And then when you multiply variables, you kind of essentially create exponents, okay? Since I have a k times a k, that's 2 k's, so we put a 2 in an exponent, okay? If I had k to the 3rd times k to the 3rd, I would have 3 and 3, so then I have 6 total, so it'd be k to the 6th. So you just add however many you're multiplying, all right? Then 4k times -9, so then that's -36, and then since there's only 1k, it just comes along with it. And then don't forget to tack on that -3k in the back, because we got to add like terms. So this 36k squared is all on its own because there's no other k squareds, all right? So 36k squared comes down. But then I have a -36k and a -3k, and I can add those together since they're just plain old k's, all right? So -36 minus 3 is -39. And then since we're adding variables of the same nature, you don't change at all. You just change the numbers. So that's it. Okay. You guys can do this one on your own, this one right here, because I want to get through these. Okay. So for this, we are going to use PEMDAS, but first we have to plug in some numbers. Okay. This is called evaluating expressions. All right. I have r plus r divided by 6 minus p. Well, I have no idea what values r and p are until I read further and they tell me what numbers they are. Okay. So anytime I see an r, I'm going to put a 6 instead because it says r equals 6. And then anytime I see a p, I'm going to throw in a 4 instead of the p. So r plus r divided by 6 minus p is going to look like 6 plus 6 divided by 6 minus 4. So I'm just replacing all of these, all the variables with the numbers that they said that they equal, okay? And now I follow PEMDAS. So I have adding, division, and subtraction. I have to do dividing first. So 6 divided by 6 is 1. And I bring down everything else. And now I'm adding, subtracting. I can go from left to right, just like normal. 6 plus 1 is 7. Minus 4 is 3. Okay? Sound good?
Yeah.
All right. So this one on the right is the same thing, but I'll let you guys do that. Let's get through this. Okay, finding angle measures. Let's recap what these angle relationships are. Remember we talked about, and I think this might have been last week. Wow. Vertical angles we talked about, linear pairs we talked about alternate interior and alternate exterior angles, and then same side interior, same side exterior angles, and then corresponding angles, okay? So I'm gonna give you hints. I would love for you guys to just shout out or write in the chat, either to everybody or privately or whatever, to me. Just give me the angle relationship with the two angles listed, okay? And I'll give you hints. So 1 and 3, all right? So we have 1 and 3. What are these angles called? They only share a vertex. They're opposite each other. They are congruent.
Exterior?
Well, 1 is exterior. But since they're both on exterior, we can't call them exterior. These are, you know, if we just had a regular X, it would be like this one and this one, right? Think vertex. They share a vertex. So it's going to be a word that kind of sounds like vertex. What do we think? They're opposite each other. They're equal to each other. A word that sounds like vertex. Think up and down, right?
Vertical.
Vertical, yeah, vertical angles. Okay, these are vertical angles. 2 and 4 would also be vertical angles because they are opposite each other. These are angles that are just, they're only bonded by that point in the middle, by that little intersection, okay? All right, 3 and 2. They are next to each other, okay? They actually share a vertex and a side, right? They share this side right here. They make a line, and a line adds up to 180 degrees. What do we think? So we have two angles that make a line and adds up to 180. What's another word for 2? Like how many shoes you wear all the time. What do we call those?
Pair.
A pair. Yeah. So this is a linear pair. Linear pair. Linear is line, right? They make a line together. They're next to each other, and there's 2 of them. Okay? So 1 and 2 are also linear pairs. 1 and 4 are also linear pairs. 5 and 8, 5 and 6, 6 and 7, right? Any angles that are next to each other that share that line, that make a line, okay? Now let's look at 2 and 8. So 2 and 8. These guys are congruent All right. They're in the same spot, just different intersections or different lines. Just remember what that one was called. Same spot, different lines. I use the directions for this one. Anything? Ringing a bell? These are corresponding angles. Okay? Corresponding. That I can take 1, 2, 3, and 4 from the top intersection, pluck it out of the diagram, and then place them on top of 5, 6, 7, and 8. And then those would match up, right? 1 goes with 5, 2 goes with 8, 3 goes with 7, 4 goes with 6. Okay? Because they're in like the same spot, just different intersections. Okay? 8 and 6. Give me 8 and 6. We've already talked about these before. They only share a vertex. They're right across from each other. What are 8 and 6? They're equal. They're congruent. What are 8 and 6? Yeah, vertical. Well done. Vertical angles. Okay. And then 6 and 1. So if you think about it, right, they're on the same side of that slanted line. They are, if I close my parallel lines and make a rectangle, they are outside of the parallel line. So they're on the same side of that line, but outside. So what do we call those? Exterior. Yep, they are exterior. And this one is, there's no fancy word. These are same side exterior, right? Because they're on the same side of that line. Same side exterior angles. And they add up to 180. Okay? So there's a little review for you. Little cheat sheet, a little rainbow review. All my different colors. Okay? Now I told you about a pattern, and I'm going to show you the pattern now. Okay? If angle 1 was 75 degrees, find all the other measures. Now, based on what we know from up here, what other angle is 75 degrees? What other angle is 75 degrees? What do we think? Think vertical. Think vertical angles. What's vertical with number 1?
2.
No, 2 is next to it, right? 2 shares that line. 4, yeah, 4 is next. 4 is vertical because it's opposite. It's opposite from 1. So that is also 75. So vertical, they don't touch. They only touch at this dot in the middle. Okay. 1 and 2 would be linear pairs, so they do something else, and we'll get to that. Okay. And now think corresponding. Which angles would be corresponding with 1 and 4 over down in the other intersection, 5, 6, 7, and 8? Which ones would be corresponding with 1 and 4? What do you think? All right, maybe just 1. Which one is also in the right, like, kind of section?
5.
5, yeah. So that's 75 as well. And then you can do vertical angles, right? Vertical down here. Which one's vertical with 5?
6.
6, yeah, 6. Well done. Yeah. So now we have our 75 degree angles. Now let's try to figure out 2, 3, 7, and 8. Let's go back to angle 1. So we have 75 degrees on angle 1. angle 2 would be a linear pair with angle 1. Okay. How do I find, and we know they add up to 180 degrees together. So how can I use that 75 to figure out what angle 2 is? What do we think? If they both add up to 180, and I know number 1 is 75 degrees, how can I get number 2? What can I do with 180?
Add.
So I can add, yeah, I mean, I can add like 75 plus some number, right, equals 180. So you can do it that way. Or if you want the shortcut answer, you just take 180 and minus 75, right? Because I have the whole thing I know, one piece of it I know, I need to find the other piece. So this is 105, I'll save you the math. And therefore, 2 is 105. Now look at 2 and 3. What are those? What kind of angles are those? Yeah, they're 105. Yeah, because they're vertical. They're vertical together. Okay, so that's 105. And now to get over here in 5, 6, 7, and 8, right? 2 would go with 7, and that's 105. 3 would also go with 8, or 7 and 8 are linear. I'm sorry, they're vertical. So that's 105. So now look at this pattern that we made. 105s. And then 75. It's like a little crisscross camp. Okay? That's your pattern. I'll show you again with this 35 really quick for number 2. So angle 1 is 35. That would mean angle 3 is 35 because those are vertical. 2 is 35 because 3 and 2 are corresponding. 4 is 35 because those are vertical. Okay? And then, give me 1 second. And then, so then all I got to do is 180 minus 35. And I get 145. And which is here. Okay? And then this is 145, and this is 145. Okay? So then here's my pattern. And then here's my pattern. Okay? So you have a little crisscross all the time. Okay? So 3 and 4 are there for you. Let's go back to the main room. So we can discuss one thing. Okay? Go back to the main room.